students. Good morning, good evening and good night, depending on which time you are going to observe this lecture. Welcome to the third lecture on hydrocarbon chapter. In this lecture, we are going to discuss the preparation of alkenes. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Preparation of alkenes that we are going to discuss. Before that, we want to spend some time on understanding what is basically alkene is. In the last two lectures, we have discussed about the different aspect of the alkane. Alkane, that is saturated hydrocarbons, where you will find all the bonds between the carbon-carbon of carbon-hydrogen. All the bonds are single bonds. Single sigma bonds. Here in this alkene means basically unsaturated hydrocarbon. Here at least one carbon-carbon double bond present in this hydrocarbon, and this is called the alkene. And now when there is a double bond in a hydrocarbon, if we compare the alkane in terms of its general formula, alkenes have the general formula, we know, that is alkane have the general formula is CnH2n plus 2, and in the this is the alkane. But when we are talking about the general formula of the alkene, at the time that you can yourself able to construct this general formula, because in the alkene there is a double bond, means it will have less 2 hydrogen atom than this alkane. So the general formula of this will be HCnH2n. And N stands for the number of carbon atoms in this hydrocarbon, and H and 2n is basically the number of hydrogen atoms in that hydrocarbon. So this is the general formula of alkene. So in the alkene there is one double bond, and the construction of double bond is that one sigma strong bond and another bond is the pi bond. That we know, that we will discuss in much detail, that you already know how this bond has been formed in the molecules between the atoms. Now we will discuss the 4 basic methods by which we can able to prepare the alkenes. That is, first, form alkyne. Again, what is alkyne? Alkyne is basically a hydrocarbon where there is a carbon-carbon triple bond present. In the alkene, there is a carbon-carbon double bond. In alkene, there is a carbon-carbon single bond. So from the alkene, how do we prepare this alkene? That is formed by partial reduction. This is basically the partial reduction. Partial reduction. Why we are talking about the partial reduction? Let us first partial reduction. Why we are calling it is a partial reduction? Partial reduction means if we reduce this alkene completely, that it can convert into the alkane, but we have to restrict this reaction up to the alkene, that is up to the double bond. So partial reduction means that we have to apply calculated amount of hydrogen in presence of a catalyst. This catalyst is called palladized catalyst. Pelladized charcoal. Pelladized charcoal, and which is again deactivated. This is again deactivated by using the poisons like sulfur compound or carry out in presence of a pelladized charcoal, which is partially deactivated in presence of poisons like sulfur compound. And this reaction is going to prepare the alkene. But here one thing that we have to remember, that in this process the produced alkene is called is having the cis geometry, that we already understand the isomerism in alkene. There is a cis geometry, that here the different type of geometrical isomerism is possible in case of alkene, whereas alkane you will not find that. That in the isomerism chapter, that in the paper we will discuss. Now we are going to discuss this reaction. So from partial reduction of the alkyne, we were able to prepare the alkene. And this is the pelladized charcoal is deactivated in presence of sulfur compound. And this catalyst is name is Lindlar catalyst. Name of this catalyst, that is the charcoal is partially deactivated by sulfur, is called also the Lindlar catalyst. Lindlar catalyst. So in presence of Lindlar catalyst, we can able to produce this alkyne. The reaction is this. That we have to always satisfy the bond of the carbon. Carbon has a tetravalent. So we cannot use this hydrogen here. We are taking another different group. We are taking this one group and this is another group, where it is plus H2O plus H2O in presence of pelladized charcoal, that is being represented by this. It is palladium, basically palladium, and it is C means charcoal. So it is going to produce and in this process you can observe that we are producing the alkene, and it is having the cis geometry. This geometry of this alkene is cis geometry. This cis geometry means the group will be same side of the double bond. Here you can see this hydrogen will be here and this. Another reaction process by which that you can able to produce the alkene, that is the trans geometry. When this alkyne, this is alkyne, when it is reduced in presence of sodium in liquid ammonia. Sodium in liquid ammonia, and this is going to produce the alkene, which having the, this is cis geometry, cis isomers, and here this will have the trans isomers. This is having the trans isomers. This is cis isomers and this is the trans isomers. Okay. So by partial reduction of the alkyne, we can able to produce the alkene, and that we are using the pelletized charcoal, and it is called also Lindlar catalyst. Lindlar's catalyst, sometime in the short note, which is Lindlar catalyst, that we have given different options, and at that option, this option will be the correct option, that is the pelletized charcoal, which is partially deactivated by poisoning sulfur-like compound. And this reaction, that is, we are taking a general reaction, that we will take the specific reaction. This is the ethine. This is ethine. When ethine is hydrogenated, the reduction process is there, and it is going to produce the ethene. This is ethene. In this process, another reaction that we can take, that is CH3CH, that is C. This is propine. This is propine. Propine, and this is going to create the propene. So we understand how to, that is the first process from which we can able to form the alkene. Now we are going to discuss the second process by which we can able to produce this alkene, that is from alkyl halide. Alkyl halides, or we can say RX. This X can be chlorine, bromine, or iodine. In this process, we can see that when alcoholic KOH is being heated with the presence of this alkyl halide, we can also change like this way. When alkyl halides is heated in presence of alcoholic KOH, alcoholic means we can take the ethanol. Alcoholic KOH means we can take ethanol, and it will going to produce a reaction which is called dehydrohalogenation. Dehydrohalogenation, and here you can observe the one molecule of halogenated acid has been removed from the alkyl halide, and this is going to produce this alkene. So reaction of this is like this. We are taking one particular alkyl halides, that is methyl halide. We are taking not methyl halide, because methyl halide we are going to produce this alkene. We require at least minimum 2 carbon atoms in the alkene. So it will be the ethyl halide. We are taking this is ethyl halide. X, maybe here X is halogen, and this halogen may be chlorine, bromine, iodine, that we have discussed. When it is being heated in presence of alcoholic KOH, you are taking this ethanol. So at that time, what is going to happen? This halogen atom and this hydrogen atom will be eliminated, and it is going to produce a double bond, that is the alkene. Here you can produce the ethane, and there is HX. And you can see this is a hydrogen and halogen has been removed from this alkyl halides. That is also, it is also called dehydrohalogenation. Dehydrohalogenation reaction, right? This is also called dehydrohalogenation, where there is one molecule of halogen acid has been removed from this alkyl halide in presence of alcoholic KOH unit. There is another name of this reaction. It is also called beta elimination reaction. Beta elimination reaction, why it is called? Because here you can see this position, this carbon atom is alpha carbon. Because in this carbon atom you will find there is a incorporation of the halogen. This is called the alpha carbon atom, and next to this alpha carbon atom is the beta carbon atom, and this beta carbon, from this beta carbon atom, this hydrogen atom has been taken out, and that is why it is called beta elimination reaction. Okay, so this is a very, very important reaction for producing the alkene. Here one thing, that in regard to the halogens, the rate of the reactions of this with the alkyl halide, that will depend on the halogen and also depend on the alkyl group present in that alkyl halides. So in terms of halogen, we can see HI, iodine. If there is halogen is iodine, then it will have the highest rate of reaction, followed by bromine and followed by chlorine. Why it is so? Because the bond strength between the carbon and iodine will be less, that it can be easily broken up. And in case of group, that is the alkyl group present here, that is tertiary group. If it is a tertiary group, then rate of reaction will be higher, followed by the secondary group, and this is followed by the primary alkyl group. Primary alkyl group. So this is halogen, we can write. This is halogen that can determine the rate of reaction, where it is the alkyl group. Alkyl group. This is like this, the rate of reaction will be this. So this is a very important reaction that we have discussed from the alkyl halides. Now we are going to discuss another reaction that is again a very important reaction from the vicinal dihalides. Vicinal halides, or this is also called vis dihalide. This is vis dihalide. In this case, what is there? When these dialkyl dihalides is reacted with the zinc, there is also found, that is the elimination of this zinc halogen compound that has been eliminated from this, and it will going to produce the alkene. As for example, you can see this is example CH2Br and CH2Br. This is the vicinal halides, but vis dihalides. Here we can see there is a two halogen atoms has been incorporated in the carbon atoms, which is adjacent carbon atom, which is bonded with each other. This is called the 1,2-dibromoethane. When this 1,2-dibromoethane is react with the zinc, it is going to produce this ethane. It is going to produce the ethane with ZnBr2. Okay, from the vicinal halides that we can also able to produce this ethane. Here also one reaction that you can see, CH3, CHBr, CH2Br, and here with the reaction with zinc, what product is going to produce? That you can see, that will be the propene. propene and ZnBr2. Okay. Now the last reaction, fourth number reaction, that is again a very important reaction, that is the acidic dehydration of the alcohol. Acidic dehydration. Acidic dehydration of alcohol. Acidic dehydration of alcohol. In this case, you know what is alcohol? Alcohol basically hydroxy derivative of the alkene. Then when one hydrogen atom of the alkene has been replaced by this OH group, this is called alcohol. And when this alcohol, that is ROH, here R is basically, you can write CnH2n plus 1O. CnH2n plus 1, this is the R, and we are continuing the OH group. When in presence of the concentrated H2SO4 or H3PO4, this alcohol is reacted, that we will taking the alcohol in presence of the concentrated H2SO4 and we heat it. Then what is going to happen? There is a dehydration reaction. The one molecule of the H2O will be taken out from this alcohol and it is the alkene has been formed. As for example, we are taking ethyl alcohol, suppose. This is ethyl alcohol. When this ethyl alcohol is concentrated H2SO4, or you can use concentrated H3PO4, and when you are going to heat it, what is going to happen? This hydrogen and this OH, that is, it becomes H2O. It is coming out from this alcohol and it is going to produce this alkene and H2O. As because there is a elimination of one molecule of H2O, it is also called the dehydration, acidic dehydration. Also we can say this is also a beta elimination reaction because the hydrogen has been removed from this beta position. So that is all the four reactions by which we can able to produce this alkene, and basically in your syllabus that the four reaction is there. There may be other process that we are not interested in that process. It is all the topics we are discussing that on the basis of as per your syllabus. So that is all for today's lecture, and if you like this lecture, you can share to your friends. This is basically a service to the students who cannot able to afford this costly tuitions. It is basically a service to them, that so that they can enrich themselves towards achieving their goals. Thank you very much for watching, and we will meet in the next lecture, that